Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast of the week starting Sunday, July 26th. Tonight we'll be discussing jet stream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a split jet stream pattern with the northern branch of the jet way up here at about 25 south, and the influential southern branch down at below 60 south, really 65 south, maybe even a little bit below that. And the ice line is right about 63 to 65 south, so most of the jet is running over ice. Not good for storm production. Anyway, we're looking for a trough, that is where the jet pushes to the north, sort of like here, but it has to be over ice-free waters. What that does is help set up a clockwise flow aloft in the atmosphere. That's the hallmark of low pressure in the southern hemisphere. And low pressure, of course, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. All right, so we don't see any troughs. We don't see anything that's going to support low pressure development. If anything, we see one area here and one area here of winds pushing to the south. Those are ridges. They do the exact opposite. They set up high pressure in the atmosphere, and that in turn pretty much doesn't support storm development. As we go into Monday, you see that one ridge pushing south, the other ridge still way south. The jet stream is down here at 65 south or beyond, all over Antarctic ice. A little bit of a trough tries to eke out here on Tuesday. All good energy, 130 knot winds, but the trough is kind of pinched off, and it doesn't last long. I mean, in 12 hours, it's gone and back to this, what they call a zonal flow, when the jet stream pushes from west to east, doesn't undulate at all, just no troughs, no ridges, and that gives nothing to set up any kind of a current or an eddy or flow circulation in the atmosphere, and does nothing to support gale development. We need gale, you need an upper level flow to support a gale. So we see something that almost is trying to develop into a trough on Thursday again, but the ice line's here. Nothing pushing north of that. Of no interest. If anything, kind of a ridge behind it pushing south. And just, this has been the pattern. We get into Saturday, more the same, not as powerful, but still kind of this eddy flow. And even where the jet does meander off to the north, winds are exceedingly weak. Let's go on out to 180 hours here, and you see, again, something that's trying to resemble a trough, again, as we get into Sunday evening, but nothing. This is in the far southeast Pacific, no real wind energy feeding it. So typically our working theory is when you're in the inactive phase of the MJO, that is when winds are blowing east in the Kelvin wave generation area, that sort of steals energy from the jet stream and allows the jet stream to fall either way south in the southern hemisphere or way to the north in the northern hemisphere. And that's how you get these patterns of zonal winds and no troughs and that sort of thing. Whereas when you have west winds in the Kelvin wave generation area, that's actually like up here on the equator in the far west Pacific, and we'll get into the details in a minute, what that does is it imparts energy to the jet. The jet gets stronger, and then it can make incursions further to the north, and that's what creates troughs. And troughs, of course, are what feed gales, and gales, of course, produce wind, which produce swell, which generates surf. So really, you need the active phase of the MJO. That's what really feeds the jet stream and allows it to make those big incursions towards the equator, and therefore feeds your storm track. Right now, we don't have that. All right, so let's dig on. Looking at surface level pressure and surface level winds, we don't expect to see anything based on what we saw on the jet, but we'll play the game anyway, go through here. Now we do see a little bit of a trough forming south of New Zealand on, not a trough, a low pressure system producing 35 knot winds Monday night, and the ice line is down here, so the winds are actually in a good place, but they're only 35 knot winds. You really need like 40 knot winds. And look at it, they actually are aimed in a good direction, but they're just not strong enough not to produce any meaningful swell. Yeah, swell for Tahiti, maybe some dribbles for Hawaii, but probably nothing more than that. I mean, maybe we'll be proven wrong, but so we keep looking. I see south winds there. Only 30 knots. We see a gale here, but that's outside the California swell window. That's only targeting Peru. Southern California is like 118 west, and all this is aimed, yeah, Mexico, maybe that area, but nothing for California, certainly nothing for Hawaii. We're into Friday, still nothing. We're into Saturday, nothing. We just see high pressure in control. That's exactly what you'd expect to see with the split jet stream flow. We know there's sort of a trough trying to organize here, and you see low pressure sort of trying to creep to the north, but no real wind energy associated with it. And here we are almost 180 hours out and nothing. So nothing, no hope there either. Let's go take a look at the wave models. Now we're going to go back in time. We're going back to Wednesday evening. There was a little gale that developed south of New Zealand. You can see here's the ice line, by the way. 62 north. That's pretty far to the north. This is like, you know, just past the peak. This is the dead of winter down there. Total, you know, blowing snow, ice, all that kind of thing. So there's less area here for storms to develop. Even if a trough and a gale does develop down here, well, it's over, you know, feet of ice. The wind gets no traction on the ocean, cannot impart energy to it, and therefore cannot generate swell. All right, so this tiny little speck of a gale developed with 29-foot seas Wednesday night, pushing, it says 32 feet right here, but it's over such a tiny area. It's like, you know, is that 100 square miles or something? That's nothing. Yeah, if you're in an island like somewhere right here, you'll get surf from it. Tahiti, we'll see something from that. And look at that. It is actually kind of lifting to the northeast. 6 hours later, 31-foot seas, and then all but gone down to 26-foot seas, and another 6 hours after that, Thursday evening. So Tahiti, we'll see something. Maybe Hawaii. I mean, you kind of look and do the math, and it's like a foot and a half maybe at 14 or 15 seconds, and that's it for a day or two. And then nothing. We'll roll this on out. You can just see nothing happened yesterday or today. Let's go at the models now, starting 18Z Sunday. We're just looking, nice little gale there under Tasmania. Lots of energy in the Indian Ocean. In fact, maybe we'll go take a look at that in just a second. But at the Pacific, now here's that one little gale that's on Tuesday. In fact, let's see, what do we get? Yeah, 20, 22, 24, 26-foot seas. That's about it. Maybe 25-foot seas. Again, that's good for Tahiti. Doubtful even for Hawaii. That would be maybe 14.5-second period swell into Hawaii. Yeah, possible. And then here we are. We're into. I mean, we're just blasting through this thing because nothing's going on. Yeah, something here for Peru and Chile, but generally speaking, and here's the system creeping under New Zealand supposedly on Saturday, falling south right over the Ross Ice Shelf. That's like right down in there. Just literally nothing, and that's the end of it. Oh, well, we got 2 more frames. There we go. Okay, the end of it. So just for fun, let's go take a look in the Indian Ocean. You'll see there is a markedly different pattern. You see where all the energy on the planet is. You know, maybe not super organized in the minute. We're just randomly looking here, but you see boom, 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 multiple 30-plus foot, there's 40-foot seas traversing the Indian Ocean over a broad area, and it gets to about a point under Tasmania and then just shuts down. See, is there any more coming here? Yep, here comes another batch. It's just cycle after cycle. It's a machine in the Indian Ocean. We talk about the low pressure bias. We'll get into that in a little bit when we start talking the ENSO. But there is a low pressure bias building over the Indian Ocean. It's real obvious from looking at the wave models. That's where all the action is. And there's a high pressure building over the Pacific, and you see the marked influence it has over the Pacific. There's nothing going on. Everything happening here. It gets under New Zealand. It dies. It's like there's a brick wall somewhere right about here, and that's the end of it. All right, so then what's that leave us? Wind swell potential. All right, for California, not even that much. Well, a little fetch of 15, 20 knot winds today off of Northern California. Yeah, there was some waist-high waves up in, San Francisco area at select breaks, but most places are even smaller than that. Main focus, Hurricane Douglas. It's now past the Big Island, supposed to pass north. It's 5.6 miles, I think, or 6 miles, nautical miles north of the northern tip of Oahu at 8 p.m. California time. That's like half an hour from now. Winds 70 knots. That's like, just off the top of my head, 79 mile an hour. Most of the fetch is in the north quadrant of the storm. Here's the low. There's high pressure here to the north. That sets up a gradient. All the energy is north of the eye. South of the eye, probably not that much. Still, down through the north shore of Oahu, winds are forecast up to 50 knots sustained. That's like 56 miles per hour out of the north at 8 p.m. We'll go take a look at some buoys and stuff maybe at some point and see if that's the case. But we were looking there a couple hours ago, and there were people on the beach. So, that might be even a bit overstated. All right, so moving on. Overnight, get into Monday. Douglas, pretty much out of the picture other than Kauai relative to Hawaii. Broad fetch, though, of easterly winds. East wind swell for the Hawaiian Islands. Pretty much nothing for California. That continues into Tuesday. Again, high pressure. The low right here. There's your gradient. There's your fetch. You can see it, east winds, 15 knots. Wind swell along east-facing shores. Nothing really for California. Notice a low pressure forecast. This seems hard to believe. Tuesday night, 30-knot winds out of the northwest. Continuing during the day, Wednesday. Maybe some wind swell resulting, when was that? Thursday or maybe Friday, I think it was, for the California coast, if this materialized. Lots of ifs there. It's pretty far out in the ocean, and this seems a little bit overhyped. Otherwise, no wind swell production. Get into Friday, still nothing. High pressure, in control for the most part. Where are we? Saturday, a little bit of local gradient starts to organize over central California, perhaps producing some wind swell there. East trades continue for the Hawaiian Islands, still producing wind swell there. We're into Saturday. Sunday, kind of looks like, junky wind swell for California, at least something to ride a week out. Wind swell starting to fade for the Hawaiian Islands, and then we're into Sunday night. Same pretty much deal, but this is that time of the year, this late July, early August time frame. I mean, you really get into where just winter hasn't started, summer's still raging. A lot of times you get these long flat spells, no southern hemi swell, and then things start waking up maybe mid-August or so. We'll see what happens, but for right now, this is not unusual, but it's not inspirational either. Hurricane Douglas, tropical storm, force wind probabilities, Big Island, where's Oahu, right? There in the purple. Oh, you can't see it. There we go. 90% probability now of, 50-knot tropical storm force winds, 35-knot winds. All right. And then the 50-knot wind probability. Let's see if we can get that up there. Here we go. Northern tip of Oahu right there in the, what shade is that? Almost 70. We'll call it 60 to 70% probability of winds 58 miles per hour or greater. That's in the next couple of hours going through, probably another couple of hours from now. So, and then Kauai right there, also looking to take a bit of a hit from it. Hopefully not. I think the eye is supposed to pass right over like the Honolulu Bay area, that sort of thing. The northeastmost quadrant of the Nepali coast. But most of the wind energy, again, north of the eye. So we'll see. We're keeping our fingers crossed for people on the islands, hoping they're taking adequate precautions and hoping that they are okay. Looking at the snow forecast, this is for the Pacific Crest Trail and Tioga Pass Resort Crossing, Tioga Pass Road, that area. Why would we do that? Well, there's a lot of backpackers up there this time of year. You're looking for temperatures mainly. No snow would be expected, but temperature-wise, maybe you're hoping for it to be cooler, not hot. We're looking at, this is the 34.6 degree line where it is, and it's all above 14,000 feet other than today and maybe the first couple of hours of tomorrow, which suggests definitely warmer temperatures, even at elevation, if you're on Pacific Crest Trail or John Muir Trail, something like that. So stay high and prepare for heat. Get going early. All right, let's go take a look long-term. What's going on with the Madden-Julian Oscillation? Of course, you know how we follow that. We're following its effect on the jet stream. And, of course, El Nino or La Nina. All right, so we're looking for the active phase of the MJO. The MJO is, of course, this periodic weather oscillation that travels from west to east on the equator. When in the active state, it can go either active or inactive. When in the active state, over the West Pacific, specifically this region in the far West Pacific, when we get a better chart, we'll show you. What it can do is reverse the trade winds there, and when that happens, it allows warm water to start pushing off to the east, but it also allows more energy to move into the jet stream, which in turn feeds those troughs that we were talking about and promotes storm development. But also, if you get successive strong active phases of the MJO, they create Kelvin waves, and multiple Kelvin waves in a row. That's warm water that travels from west to east across the Pacific under the equator, driven by a reverse of trade winds here in the West Pacific. That, in turn, can feed the development of El Nino. All right, so right now we're looking at the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here, West Pacific here. 0, that is the equator. There is New Guinea there. The international date line is right there. We're just looking at the arrows you see. These are from the series of buoys strung across the equator used for monitoring El Nino, but they give us 5-day average winds. They're not giving you hour-by-hour winds like the buoys off our coast or off Hawaii, but they give you a rough idea what's going on MJO-wise. You see the arrows out of the east, trade winds, pretty strong. Arrows are pretty big over the Central Pacific and into the Kelvin wave generation area. So this is definitely not an obvious sign of the active phase of the MJO. Anomalies, so these are blowing hard, but, sometimes of the year, winds blow hard, sometimes they blow less. So we look at anomalies, differences from normal for this time of year. There's no arrows here. That means pretty much this is normal for this time of year until you get to the Central Pacific, and then you start seeing these arrows out of the east, meaning the trades are stronger than normal in the Central Pacific, stronger than normal here over the Kelvin wave generation area. That is definitely a sign of the inactive phase of the MJO. All right, looking at the forecast, this is the whole planet on one chart. The Pacific starts at about 135 east on the equator, and it goes the whole way to about 80 west. That's where Ecuador is. Okay, the West Pacific, the Kelvin wave generation area, that's the area we're interested in. 135 east to about 170 west. So from there to there, and you just draw a line right up the chart the whole way, and you look in that zone. And this is what the winds have been doing, the east-west component of the wind. Are they blowing more from the east or more from the west compared to normal for this time of year? And then by date. So you can see there's lots of blues. Blues are easterly anomalies. A prevalence of easterly anomalies all month of July. Pretty strong, in fact, there in July 6th through the 11th or so. Backed off a little again. Another even stronger burst going on right now. No surprise we have easterly anomalies. And forecast to continue, but not only filling the Kelvin wave generation area, which ends right here, but Ecuador is like here. And you see easterly anomalies filling the entirety of the Pacific a week out from now. So that is not only the inactive phase of the MJO, but it's the inactive phase filling the entirety of the equatorial Pacific. That suggests that there's no big push for storm development going to happen in the next week. It doesn't mean it can't happen, but it definitely suggests, well, looking at this whole thing, easterly anomalies have been in control. And typically you get like 4 weeks of active phase, 4 weeks of inactive phase. Instead, all we're seeing is just inactive phase nonstop. And this is what we were kind of worried about getting into this summer. We've been lucky. We've had some swells. I hope you got some of it because this sort of speaks again to the La Nina issue. We'll get into that more in a minute. All right, outgoing long wave radiation. Fancy word for cloud cover. Yellows and orange mean less cloud cover. Blues mean more cloud cover. This means the inactive phase of the MJO. And this is the statistic model suggests inactive phase in control, fading. Oh, Kelvin wave generation area. That's right. So let's talk about that real quick. 135 east. So there's New Guinea. There's the Philippines, Australia, South America. The equator, 0, right down the middle here. Kelvin wave generation area, 170 west, 5 degrees north and south of the equator. So draw a box in your mind right around there. And that's where you want to see the active phase of the MJO and westerly anomalies. So we certainly don't see it here. We see just easterly anomalies or no anomalies. Then we get into, we'll say 10 days out. Hey, there's the active phase of the MJO. And there it is again, building stronger 15 days out. So according to this model, there's potential maybe 2 weeks from now for some westerly anomalies. So some potential for storm development. And then we look at the dynamic model, and it's just a mess. It's all corrupt, so we can't get any clues from that. But remember, this model is not everything. We've seen multiple instances where the statistic model says one thing, dynamic model says something totally different. So we're not going to buy into anything, but we're looking for clues. That's where we're diving for dollars here. All right, let's keep going. Phase diagram charts. All right, so the good news is we have the statistic model and the dynamic model, so we can get a clue of what's going on. What are we looking at here? We're looking down on the North Pole, and the equator's out around here, right? And the MJO moves from west to east, from the Indian Ocean over the maritime continent, across the West Pacific, over the East Pacific, under the United States, over the Atlantic, over North Africa, back to the Indian Ocean. Both the inactive phase and the active phase move that way. Wherever the active phase is, the inactive phase is on the other, exact opposite side of the chart, other side of the planet. So in this case, the heavy dots where the active phase is, the further it is away from the circle, the stronger it is. So the active phase, no big surprise, is in the Indian Ocean. That's where all the storms are. That's where the jet stream is doing its thing, right? Okay, the forecast is for it to weaken and collapse over the maritime continent 2 weeks from now. This per the statistic model. The dynamic model says exactly the same thing. So that sort of hints that maybe that other chart we saw before, that there is going to be some sort of active phase activity move into the very far West Pacific 2 weeks from now. But it's probably going to be very weak and will probably collapse pretty quickly and not be a massive source of energy in the jet stream. Okay, upper level model. This goes out 40 days. It goes out a little bit longer. What is this about? Potential for precipitation. So there's South America. The equator is, where's it hiding? Right there, 0. Okay, Kelvin wave generation area right there. There's New Guinea. Date line is roughly right about there. Orange and yellows, so these are not easterly anomalies, but it's sort of the same thing. These are areas not favorable for precipitation, so one could read that as the inactive phase of the MJO. So, and this is a statistic model. This suggests the inactive phase moving out of the Pacific about August 10th, something like that, with a weak inactive phase showing up in the West Pacific about the same time, and then getting stronger in the Pacific, we'll say middle of August into early September. So that would be our window when we'd expect, hey, and that's, kind of right on cue. We were talking somewhere around mid-August, the storms and the swells start pumping up. Well, this would support that. It's a weak active phase, but that would impart some energy to the jet stream and perhaps feed the storm track. All right, so that's some good positive news. Let's keep digging. Here's the CFS model. East-west component of the wind, okay? The blues, easterly anomalies again. All right, so Kelvin wave generation area, run it right up from there to about there. And what do we see? Well, the whole month of June has been building easterly anomalies. No sign of the MJO. This dotted or solid black line, that's the MJO. It's all isolated to the Indian Ocean. Active phase building there August 8th. Okay, but nothing in the Pacific. This is the high pass filter. This is we'll just say it's a high pressure bias over the Pacific. There is no low pressure bias indicated here for the moment, but we suspect that will change as we get into fall. Anyway, easterly anomalies in control. Today, same deal, making their way to a point south of California on the equator, and then even building their coverage the whole way to Ecuador. What is this, a month out? So no sign of the active phase of the MJO, and only easterly anomalies in control. That's not good. All right, so then we go out 3 months. This is the 3-month CFS model, 850 millibar zonal wind anomalies. Okay, this is past performance at the bottom. This is the forecast here. Kelvin wave generation area, again, starting along that line there and going to about there. And this is where we want to see the activity. This is where the energy gets imparted to the jet stream. Today, the blues, easterly anomalies, it's indicative of the inactive phase of the MJO. And then the good news is we see come September, looks like westerly anomalies start building in the Pacific and then start trying to get a foothold and actually taking over the Pacific as we get into October. Now, we're not sure, I don't believe a model a week out, much less 3 months out, but it sort of suggests that we're in a really bad phase, maybe the worst of it in the next, come August 11th or so, and then maybe we'll get into a moderating pattern, if you believe this model. Let's overlay the MJO here. All right, dotted contour, inactive phase of the MJO. It's in the Kelvin wave area, generation area today, and supposed to hold in some fashion till about middle of September. So that's another month and a half, 6 weeks, 7 weeks from now. Easterly anomalies strong and in control, and then the solid line, a pretty strong active phase of the MJO forecast to usher in fall, but westerly anomalies not even making it to the date line. So that's kind of suggestive of these easterly anomalies are here for the duration. Then you get an inactive phase of the MJO here, with westerly anomalies still hanging on. That's a little bit suspect for sure. Let's overlay the low-pass filter. This really tells the story. Okay, this contour here, this dotted line, is high pressure sitting right on the international date line. High pressure is not conducive to storm development. And the low pressure bias right here, the solid contour, where is it? Right smack in the middle of the Indian Ocean, and only built, it's not even officially present today. It's only supposed to start building as we get into mid-August, which means, and the high pressure bias, it's there today, only supposed to get stronger to 3 contours as we get into, October. So this suggests that the pattern that we're seeing now is only going to get more entrenched as we get deeper into fall. And again, that smells very much like La Nina. In fact, this model is pretty much calling for La Nina development in the Pacific. And we know that La Nina is not great for storm development during winter months. It tends to cut down the number of storms, their strength, their duration, which therefore cuts down the number of swells, the size of them, and the duration of them. All right, so enough of the MJO. Let's go talk about El Nino, La Nina. All the models are suggesting a push towards La Nina. What's the ocean say is going on? Here's where things get kind of interesting. All right, so again, TAO buoy data. Here's the West Pacific. Here's the East Pacific. Here's the actual anchor lines on those buoys. The X's are sensors on the anchor lines. You take all that data, beam it up. I don't know how often they do this, maybe once a day. Pushes it up to NOAA's headquarters up in Maryland, I think it is. They run it through a model, fill in the gaps. You get a profile of subsurface temperatures. During El Nino, you get warm water over here. During La Nina, you get colder water over here, and all the warm water's balled up to the west. I mean, it normally is. You just get this incursions of warm water pushing off to the east during El Nino. All right, so the 29-degree isotherm, right here at 180, that's about where it's been. The 28-degree isotherm, this is 28 degrees centigrade. 160 west, that's where it was last week, no real change. 24-degree isotherm, it was at like 115 last week. It's moved a degree or two, but really no change, which is kind of good news because the models have been suggesting La Nina development, cold water building here. All right, let's go look at those are actual temperatures, the anomalies, differences from normal for this time of year, and you see pretty much a neutral pattern. Yeah, a little pocket of warming there, a little pocket of warming there, a little pocket of cooler water off Ecuador, but nothing, no marked change. A couple of months ago, massive pocket of cold water did just like this. It formed like under the date line, and acted like a Kelvin wave pushing off to the east and got colder and colder the closer it got to the coast here, and then upwelled to the surface, and it has created a bit of a problem for us, and we'll see that in a minute. And now that pocket that is there is all but gone, fading out, but a new one is developing. You know, I don't know whether you can call it a Kelvin wave, because Kelvin waves are typically associated with warm water, but this looks like cold water Kelvin waves propagating under the equator from west to east. So again, that smells of La Nina, certainly not of El Nino. So here's the same data, but using another model, the GODAS model, GODAS. It runs about a week behind. Here's the cool, and it goes further off to the east to 80 west, right up to Ecuador. Here's that previous cool pocket, the first pulse of the cold water Kelvin wave impacting Ecuador, still there today. Here's our developing, here's one pocket here, and it almost looks like another trying to, this is exactly, another trying to develop in the far west Pacific. This is exactly what El Nino development looks like, but it's the exact opposite. Instead of cool water here and warm water pushing across, it's reverse. It's cool water, bundles of water working their way west to east across the Pacific. So that smells very much like La Nina. To put things in historical perspective, okay, last fall, here is warm water. This is the West Pacific here, East Pacific here. These are water temperatures. Upper ocean heat anomalies, they call it. But you basically see warm water moving from the West Pacific to the East Pacific over time, erupting off of Ecuador in the December timeframe. Another Kelvin wave, warm water Kelvin wave, tried to get organized, driven by the active phase of the MJO, stalled mid-Pacific. Another active phase right behind it, pretty much sealed the deal, brought the warm water in. And then here was that first pocket of cool water. Trade started picking up out of the east, started creating upwelling. Cool pocket emerged. This is under the equator in April, May, erupted off the coast here. We'll see in a minute the effect on surface waters, and now you can see the evolution of that next cool pocket starting to happen under about 160 west, 150, something like that, suggesting maybe another cold Kelvin wave on the move. Okay, sea surface height. The height of the ocean surface from JSON-3 satellite, strip out all the wave heights, strip out the wind waves, strip out the tides. And is the ocean higher or lower than normal? What's that mean? Well, if you have cold water at depth, it contracts, creates a little divot on the ocean surface, and you get these negative numbers. -5 centimeters. That's, you know what, something like that. Pretty small amount. So 5 centimeters on the equator, but all up and down the Central American coast, down Peru, suggesting cold water in this region right here, where typically you'd want to see positive anomalies if there were warm water inflow. So all this suggests is that a cool regime, or at best a neutral regime, is in control. All right, sea surface temperatures. This is kind of where the rubber meets the road. The temperatures on the surface is what affects the atmosphere above it. If you want evaporation and therefore condensation and cloud development, which is the hallmark of low pressure, you'd want warmer than normal water. Well, we certainly don't see that. The blues, cooler than normal, off of Ecuador, here we go, down, Chile, Peru, Ecuador, then streaming along the equator the whole way out to the date line, and a little bit colder right here the past couple of days. Not a huge pocket, and the general trend is not getting colder, but over a broad area, not giving up any ground. This is the trend for the past 7 days. It's just, is the water getting colder or warmer than normal? The blues, colder than normal. You see right there off of Ecuador. Galapagos are right there. But then beyond there, little pockets of warming, little pockets of cooling. Basically everything holding steady state other than right here. And then finally, just sea surface temperature anomalies. Differences from normal for this time of year. And you can clearly see cool water off Peru, off the Galapagos, over the Galapagos, off of Ecuador, extending the whole way the date line, 180 west right there, to the date line. Now there's warm water around it, mainly to the north. You see there's, actually neutral to cooler water even down here, but it's just 5 degrees. So the official El Nino monitoring region from 120 west, 5 degrees north and south of the equator out to 170 west. So right there, you say, well, there's warm water wrapped around it, but there's also cool water in the core of this Nino 3.4 region area. And just to be clear, the sea surface temperatures, if they're half a degree below normal for 5 consecutive months in the Nino 3.4 region, then that's enough to declare La Nina, at least from a sea surface temperature perspective. Likewise, half a degree above normal, you're into El Nino. All right, so the Nino 1.2 region, this is the area right up there by Peru. What's the temperature trend be? Well, there's neutral. You see it's just been steadily falling down. Today, minus 1.526 degrees. It was down to almost 2 degrees there a week ago, something like a week and a half ago. But the trend has been definitely La Nina-ish like in the 1.2 region, but that's not the official region, though. You know what? We use this as an indicator for rainfall potential in California, and if this is colder than normal, pretty much signifies a drier year in California. We'll see if that holds true this winter. The official El Nino 3.4 region temperature index, well, it dipped down there back in May, down to a little over half a degree above normal, but today, dead neutral, 0.06. So remember we were talking about that balance of the warm water and the cool water in the official region? So we're not in La Nina officially, though it certainly looks like it, and there's a host of data that suggest it, but some of that data is lagging indicators, but this would be a leading indicator. And we're, you know, the real leading indicators, we see that ball of cold water, that cold Kelvin wave, the second ball getting ready to make its way across the Pacific. That'll arrive, 5-6 weeks from now. And at that time, we would expect to see these temperatures starting to drop off. So what's going on in the atmosphere, all right? We've talked subsurface, things definitely look cold. We've talked Kelvin wave generation area, things definitely don't look good there, mainly east anomalies in control. We've talked the atmosphere, high-low pressure bias, definitely looking like we're moving towards a La Nina, high pressure setting up over the dateline. Southern Oscillation Index, what's going on right now? Not a forecast, just is pressure higher or lower than normal? This index is called the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. And a lot of that's just driven by where are there stations where you can stick a barometer, right? You can't stick a barometer in the middle of the ocean where there's no land, and you can't have 100 years worth of data and somebody can't be there reading it. So that's how this kind of all evolved. There's been people in Tahiti for years. Same with Darwin. They've had barometers. They measure. Someone every day goes out and reads it and writes it down, and then you can take that and do some stuff with it, some smoothing of data, and build trends out of it. All right, so today, the index is 6.09. A little bit pressure. That means pressure's higher than normal in Tahiti. And you can kind of go back and see, yeah, it's been pretty high. It's been positive for days now. It's kind of dipping around, but just eyeballing the numbers, it generally looks to be positive for the past month. 30-day average, sort of average that out. That gets some of the noise out of the numbers today. Plus 5.62, so its pressure is higher than normal in Tahiti. And where was it a month ago? Minus 7.95, minus 9. So pressure is rising. That's suggestive of La Nina. The 90-day average, that even takes more noise out of it. Minus 0.24, dead neutral, as neutral as you can get. Neither El Nino nor La Nina. And where was it a month ago? Minus 2.62, so pressure is rising. This is very much a lagging indicator. 90-day average, it's running 90 days behind what's happening today. 3 months behind. So, to me, the leading indicator would be that pocket of cool water we're monitoring under the Pacific. It hasn't erupted yet, but that's giving us like a 2-month lead on what the atmosphere might be doing, because once that cool water erupts, we know it's going to feed high pressure in the Pacific, and it's going to start pushing this index up even more. So we have our leading indicator. This is our very much lagging indicator, but we see even from it, pressure is rising in the Pacific. It's neutral, but if it keeps going for another 3 or 4 months like this as we get into late fall and winter, then that would smell of La Nina. Let's look for a trend in this 30-day Southern Oscillation Index, all right? Your up phases here are the inactive phase of the MJO. The down phases are the active phases of the MJO. Today, we're on a pretty good run up into the positive of the active phase of the MJO. And we're kind of looking for a trend. And you can see, well, last winter, late in the winter, we were kind of almost El Nino-ish like. But if you put an average line through this, we're definitely trending upward. Still, not even at neutral yet, you know, just eyeballing a trend line here. Not even neutral or right at neutral. So, we're not in La Nina, but it's certainly everything, all the leading indicators suggest that's exactly where we're heading. And then finally, sea surface temperature forecast from the CFS version 2 model. All right, no change here from what we've been seeing. We were warm last winter, but we were cold in the summer. And that predisposed the jet stream, sort of made it feel like La Nina. And even though we warmed up and temperatures went up half a degree, 0.6 of a degree above normal, we were all, the atmosphere is a big boat. It takes a long-term time to move. And the cold pulse last summer pretty much doomed us in fall and winter. And yeah, we tried to get some traction, but now we're falling right back into the exact same hole. Now, this is a forecast. Right now, we were looking at temperatures, and officially, we're right here. The model says we should be about half a degree below normal and continuing to fall into a hole as we get into fall down to minus 1.2 degrees, which would be a pretty strong La Nina. We don't think that's going to happen. We'll probably be down about 0.7 or something like that. But still, that'd be La Nina. That'd still be enough to stomp on the jet stream, stomp on the storm track for this winter, dry things up from a snow and rain perspective into California. So, again, no big change, not looking good. But, we kind of had this La Nina thing last winter. If we have it this winter, that pretty much will be it. We'll be out of the woods, and then we'll probably be moving towards a neutral phase after that. So we have the July update. This is a summary of all the different dynamic models and statistic models used that everyone's using to try to track El Nino, La Nina. Last time we looked, this thing was pretty much showing neutral with a couple of members of the model suggesting maybe a weak dip to La Nina. Now you can see the, where's the average here? The CPC consolidated right here. Average of dynamic and consolidated models suggests down to minus 1 degrees from, so how do you read this? It's August, September, October, November. So we'll just say August, September, October, November. You see the drill here. Temperatures dropping pretty much in line with what we saw from the CFS model the whole way through about January and then starting to rebound. The CFS model, where is it? Right there. NCEP CFS version 2. The green, which is hiding right down along here, which is even more pronounced than the average. And this is the green and the red are the dynamic and statistic model averages, which are showing weak La Nina. The CFS is even down below that, down below this average. But either way, you get the sense that, 0.7, 0.8 degrees below normal. That's still definitely La Nina. It seems like it's in the cards, all the models, except for a handful up here, which are, there's always some part of your population that's in denial of reality from a modeling perspective. And all we're saying is, that's right, they're entitled to, those models can think what they want to think. These other models down here can think what they want to think, but probably somewhere in the middle is reality. And that reality is definitely towards negative temperatures, definitely towards a La Nina type approach. That doesn't mean it's going to happen, but when all the models are pointing that way, you're looking at the data and it suggests that you're probably ending up that way. So for now, no real southern hemi swell is in the water. We'd love to say there is. There's a tiny little bit of energy that might show up for Hawaii, but nothing for California. Literally nothing on the models. Wind swell is the only hope. Probably a good time to go take care of chores, do other sorts of things, go train, stay in shape, swim, whatever you do. If there are little wind swell waves, go ride them, have fun, make the most of it. Stay away from other people as much as you can, but try to have a good time. Long term, it looks like we're moving towards La Nina. The models are all starting to come into agreement. Some of the models were early early adopters picked up on the trend. We've been sort of suggesting that that has been the case. The others are following suit now. And so it doesn't look great for this winter. It looks like a dry winter for California, below average surf. And when the surf does come, could be windy, could be inconsistent, all those sorts of things. But, you know, got to pay the price. We've had a couple of pretty decent years in recent memory. These things go on scales of half decades at a time, not months or weeks, you know. So we got to be patient and just make the best of it. By next year, it could be a whole different story. And with the COVID thing going on, it's probably better to be safe than to be sorry. I mean, vaccine work is underway. Good minds are working on things. There will be better days ahead. You have to believe in that. Don't get yourself too down. I'm not. We're just use this as an opportunity to go take care of other business right now, but stay in shape so that when there are waves, you can do something about it. All right, so if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, subscribe. You know, click the subscribe box down there, ring the bell, you get notifications. You don't want to do that, go to stormsurf.com. All the data that you have seen here is available. You can look at it 24/7. We will post the link to the video there tomorrow, and you can watch it from there. And other than that, thank you for watching. Stay safe, my friends, and we will see you next week. Same time, same channel. Thanks for watching.